How will we power our future? Can we create a healthy and clean economy? Climate One at the Commonwealth Club is at the forefront of the global debate about energy, economy, and the environment. Bringing together the brightest and most provocative leaders of our time, Climate One is the place where big ideas get heard. With thoughtful and insightful discussions on policy, business, science, and culture, Climate One founder Greg Dalton gets to the heart of the matter. It's our future. It's time to come together.
When the Paris Climate Agreement was reached in 2015, world leaders raised their arms in triumph, as nearly every country agreed that climate change is a problem caused by humans and needs to be addressed. On the show today, we'll take the pulse of the deal. Is it flourishing or floundering? Katharine Mach is senior research scientist at Stanford and an adjunct assistant professor at Carnegie Mellon University. She was a co-leader of the IPCC working group on impacts, adaptation, and vulnerability. Trevor Hauser is partner at the Rhodium Group, which analyzes the economic risks of global climate change. He also has worked at the U.S. State Department on U.S.-China energy and climate relations. Later in the show, we'll look at other countries for what's working and what's not in the fight to slow and eventually reverse global warming. Katharine Mach, let's go to that day, December 2015, in Paris. The world was there. World leaders came together after it failed in Copenhagen. They came together in Paris. What were your recollections? How did you feel when that deal was sealed?
It was really an amazing moment in the climate challenge. It was one where, from my scientific perspective, a key underpinning was just a recognition that climate change is happening around the world, every continent. There's also the sense that solutions were possible. Costs were dropping in terms of solar and wind. And then the real backdrop was just the level of cooperation. Jumping back 1 year, US and China coming together with their joint announcements and just really everything else falling into place.
So great. So some optimism, some cooperation. Trevor Hauser, you were in Paris, but you also were in Iowa advising Hillary Clinton. What's your recollection of that moment?
I think I'd been in Paris the first week of the conference and then had to leave to come back to the States. And, because of the U.S.-China joint announcement the year before, I think folks were pretty confident going into Paris that it would be a better outcome than Copenhagen had been several years before. But these are always, 11th hour high wire acts. And I remember breathing a pretty big sigh of relief when that 11th hour came out well in Paris, and that for the first time we had all countries, save at that time Syria and Nicaragua, and ultimately including Syria and Nicaragua, agreeing to a common approach to addressing climate change and setting long-term goals and signaling pretty loudly to the world that we were all headed in that direction.
Katharine Mach, there's a lot of talk between the difference between 2 degrees of Celsius and warming since post-industrial times. And then there was this kind of surprising appearance of 1.5 degrees that came into Paris. It was like, wow, this is I remember being there and talking to Mike Brune, head of the Sierra Club. He was pretty upbeat. It's like, yeah, this is this is a little better than we thought. So tell us the difference, how that came in, and also the difference between 1.5 and 2, because it's hard to understand what that really means.
Yeah, so to a really unprecedented degree, science directly informed the goal setting around what should the limit be. And indeed, we're now pursuing a limit of well below 2 degrees Celsius and with 1.5 degrees Celsius in sight. So in some ways, where that came from was, first of all, a recognition of the degree to which climate change impacts are already happening. The last full-blown assessment out from the Intergovernmental Panel on Climate Change came out in 2013 and 2014, and it was teasing out impacts system by system. It's the frontline systems, the coral reefs, Arctic sea ice. It's the degree to which we're seeing impacts in extremes, floods, and fires. It's also really the unevenness of those impacts for communities already on the margin, whether that's food or water insecurity. So in terms of where 1.5 degrees Celsius came from, it was really the fact that this is happening now, and we know the risks go up. And there's some really important thresholds, whether it's sea level rise and the collapse of the West Antarctic, Greenland, or other questions that are more about ecosystems shifting into other states where it's really hard to get back.
And Trevor Hauser, there's sometimes you think there's a sort of a binary idea that like 1.5 below everything's okay, and above 1.5 there's Armageddon, but it's really more of a continuum, right? In terms of what happens between 1.5 and 2. So what are the economic risks of 1.5 and 2, and what are we really looking at along that continuum?
Yeah, I mean, I think that it's 1.5 degrees is a lot better than 2 degrees. And for some particularly vulnerable communities, low-lying island states, over a long period of time, the difference between 1.5 degrees and 2 degrees can be existential. At the same time, it's important as we focus on those long-term goals not to lose sight of the really enormous benefits in terms of risk reduction that we're delivering by reducing what was previously a trajectory of emissions of 6 degrees or 7 degrees down to 4 or 5 degrees to 3 degrees. Each one of those reduction in future warming is going to save hundreds of millions of lives around the world, save billions of dollars in economic costs. And it's important not to lose sight of that progress that we're making along the way as we shoot towards that either 2 degree or 1.5 degree target.
So Katharine Mach, is Paris healthy at 3 years old, or is it a little kind of sickly child?
I guess we've made it through the terrible twos is one way of thinking about that question. I mean, I think the world does look different in year 2018 as compared to 2015. I think hands down in the space of climate change impacts, we're just increasingly understanding that this is something we need to grapple with, not just in terms of reducing our emissions of heat-trapping gases, but in preparing for increased precipitation when a cyclone strikes shore, increased risk of fire. That dimension is part of the Paris Agreement, but I feel like it's something that we're seeing more and more.
Trevor Hauser, oil demands, there's been more oil used for 5 years. We're going in the wrong direction?
Yeah, so we've made a lot of progress in some sectors of the economy. The cost of wind and solar power has declined dramatically. We've seen in the U.S. a replacement of lots of coal generation with natural gas, record amounts of wind and solar being added in India and in China. Electricity is a pretty significant part of emissions, about a quarter of greenhouse gas emissions in the U.S., but it's still only a quarter of greenhouse gas emissions, and it turns out that electricity is the easy part. Reducing transportation-related emissions, reducing oil demand is really hard. People are pretty attached to their cars, and turning over those vehicles, getting more efficient cars, more electric cars into the vehicle mix just takes a lot longer than changing over the power system.
How about the impact of the change in U.S. leadership? You've been in the diplomatic circles, the change of a U.S. president who, particularly in his second term, made climate somewhat of a legacy issue, Trevor Hauser. What has been the change of the U.S. president? Probably doesn't mention climate in the top 3 issues when he's going to a foreign country these days.
Yeah, I think it's pretty hard to overstate the impact of that change in U.S. leadership. I mean, there has been, following Donald Trump's election and his announcement of the U.S.'s intention to pull out of the Paris Agreement, as Katharine said, there's been this kind of groundswell of state and city action in the U.S. Trying to do their part to help keep the U.S. on track. That's helpful, but it's far from sufficient. I think the thing that people didn't see about the Obama administration in public, and that really is lacking now, is in almost every head of state meeting that President Obama had, he made climate change one of the top 3 discussion points. And the leaders that he was meeting with knew that he was going to make climate change one of the top 3 discussion points. And if you are the president of Bangladesh or Chile or Germany, and you're meeting with the U.S. head of state, and you know he's going to ask you about what climate policy you're taking, that drives domestic policy focus in a way that few other things can, and that's completely gone now. I mean, if anything, the opposite is true, that the current president creates a moral hazard opportunity for other leaders to backslide, and I think there's really no other country that can play that role in the way the U.S. can.
Katharine Mach, there's the Climate Action Tracker that kind of rates countries on their climate action. Basically, these are my grades, but they have different categories for these. But basically, the failing grades are Russia, Saudi Arabia, Turkey, USA, and Ukraine. The D, the next worst categories, Canada, China, and Japan, South Korea. Australia, Brazil, and EU and Mexico get basically an average grade for trying to meet the Paris goals. And B, better than average, Costa Rica, India, Philippines, and only Morocco and Gambia get sort of the top rating, interestingly, countries that have contributed very little to the problem. So tell us about that distribution of, most of these countries aren't doing very well.
Yeah, so it's this tool where you can look up any country and in particular think about how climate change responses are going in the space of reducing emissions of heat-trapping gases. I think, as Trevor emphasized, the powerful feature of the Paris Agreement is that all countries have come forward. So in this tool, you can basically look at everyone, even though it's worth highlighting some of the biggies, right? So at the biggies side of the table, you've got China, 10 billion tons of CO2 into the atmosphere each year. We're seeing exponentially increasing deployments of solar and wind. That's powerful, but then the real question is what's happening with coal? That's ticked back up. That's part of the decision there in the climate action tracker space. What's happening with the full energy set of services that must include buildings and transport? What's also interesting in that climate action tracker is it goes for every single country. So Morocco, huge deployments of solar. Costa Rica, same goes. But I think what's also kind of neat is that if you say, well, which countries are being really creative and demonstrating leadership in grappling with the impacts of a changing climate, you'd put a lot of the smaller economies on that list too, whether it's community-based action addressing agriculture or the degradation of ecosystems that increases flooding. Just about every country around the world, we see progress on that space of grappling with the fact that climate change is here and now, and not just the far-off aims towards long-term decarbonization of the economy.
Trevor Hauser, there's some suggestion that there's a recent climate conference going on in Poland, negotiations. There's some suggestion that the U.S. is going from kind of benign neglect, where President Trump would tweet some nasty things, say some dismissive things, but the engine of government would kind of be there and sort of supportive without getting in trouble. But there's some suggestion that there's now U.S. is actively trying to stick a dagger into the Paris Climate Accord. What's your take?
So the highest stakes drama going on in Poland right now is the drama that's not getting reported in the press. So all the theatrics around whether the international community would welcome or take note of the UN report is important, but not the thing that matters most out of the outcome. What's highest stakes is what's happening behind closed doors in very technical negotiations around the framework architecture of the agreement. And I have what's hopefully not poorly founded optimism that the career civil servants at the State Department are doing their best to protect a framework there that will survive the current administration.
Worldwide emissions of greenhouse gases reached an all-time high in 2018 after several years of being mostly flat. Clean energy continued to advance with a record amount of new solar capacity added, and nuclear power also advancing with about 50 new plants under construction worldwide. Joining us to discuss the paths to increasing energy production while cutting carbon pollution are three experts. Joshua Goldstein is Professor Emeritus of International Relations at American University and co-author of the book, A Bright Future: How Some Countries Have Solved Climate Change. Sonia Agarwal is Vice President at Energy Innovation, a consulting firm. And Staffan Kvist is an energy consultant and co-author with Joshua Goldstein of A Bright Future. Sonia, let's begin with you. As you look around the globe, who's doing the best? Who's winning the race to change their economy and their energy before climate really gets bad?
Great question. We here in California actually like to, there's a lot of folks in Sacramento who kind of consider us to be a separate country in and of ourselves, right? So it's now, if California was a separate country, it would be the fifth largest economy in the world. And so it matters a lot what's going on here. And Here we have a suite of policies which really look at each of the different sources of greenhouse gas emissions, whether it's power plants or factories, cars, buildings, agriculture, and have set targets and put together really detailed policies to move us to a lower carbon system overall here. So I would say, honestly, California is doing quite well. There's also, of course, quite a few other countries that are really moving quickly. I would say also in Europe, if you look at Spain and Ireland, there's a lot of progress there. I know some of my co-panelists will also talk about some other progress in Europe too. But it's been pretty amazing to see how the market has taken off to really bring down the cost of clean energy and what impact that's making in a lot of different places around the world.
Joshua Goldstein, let me challenge a little bit even the question of, the title of the book, which is, I'm not sure that any country has really solved climate change.
Well, nobody solved climate change, but the reason we call the book How Some Countries Have Solved Climate Change and the Rest Can Follow, we're talking about a path that no one country can solve climate change. It's a global problem. We're talking about a path to decarbonize the world. We need to decarbonize the world economy really quickly and at massive scale. And the way that some places are doing it, and I would include California in this, they're moving in the right direction, but it's not fast enough, and it's not a path that could actually realistically get to the goal by mid-century. Other countries, and we talk about Sweden quite a bit, Stefan's country, France, Ontario, South Korea, have added clean energy much faster. And we're interested in that model and how it could apply to the world as a whole. The metric that matters here is carbon going into the atmosphere. It's not what you say, it's not how many renewables you put in or how many nuclear plants you put in or how many protesters you get in the street, it's how much carbon's going up. And you don't need to take our word for it. There's a wonderful website called electricitymap.org that shows how many grams of carbon for each kilowatt hour of electricity. How dirty is your electricity for the countries in the world and for the states within the United States or regions. And if you look at that, you can see who's green, color-coded green, that's very little carbon going in, and who's really brown, a lot of carbon. California's in the middle on that. Sweden and France are really green, and they're doing it with nuclear power primarily, in Sweden's case, nuclear and renewables. There are also countries that can do it with hydroelectricity, but that's very hard to expand because many countries don't have that resource. So we want to turn that map green, and we have very little time to do it, and it's at a large scale.
Stefan Quist, tell us your European favorites. So, Sweden, of course, it's easy to dismiss small Northern European countries with small populations. Singapore, Nordic countries is like, it's easy for those small, more socialist countries to do things. But tell us the case for those.
So when I look at a problem, like I was renovating my house, I always go to YouTube and I search, how do you do this? And usually that's a good way to look at a problem. Has anyone actually managed to do what we're trying to do? And the first step of what everyone is trying to do is decarbonize the electricity grid, because that's kind of the low-hanging fruit of decarbonization. And throughout my entire lifespan, I was born in 1986, Sweden has had a completely decarbonized electricity grid. So for me, it was obvious to see what did we do, how long did it take, how much did it cost. Obviously, it's a small example, but basically France is a similar example at a much larger scale. But Sweden is kind of the size of a typical US state. And so you could make the argument that if every state did like Sweden, that would add up to United States, for instance. But France is a similar story on a much larger scale. So there are a few examples, but obviously we have this big problem because there aren't a lot good examples. There are only a few good examples. But what I was starting to look at in my academic research is how did Sweden do this? How did France do this? How quickly did it happen? And how much did it cost? And so those stories, I think, are stronger than energy systems modeling, which I also do, because they actually happen in real life.
Of course, we talk about France. You have to talk about the recent yellow vest protests, Sonia. A lot of the people on the right, Heritage Foundation, were very quick to point out, aha, you try to price carbon, raise gasoline taxes, there's revolutions in the street, which could send a chilling effect to some politicians thinking, oh, we don't want to have that here. But it's actually more complex.
I totally agree. Yeah, so there's a lot of different things going on in France at the moment in terms of their overall economic policy. So one of the things, of course, is a list of carbon-oriented, climate-oriented policies. But at the same time, there's a lot of broader immigration and economic issues that are going on as well. I think that without a clear plan to bring communities along and bring working people with you on the solutions, it's going to be a lot harder to get there. But I don't think that it's a one or the other here on pricing carbon.
Stefan Kvist, you write about 3 Mile Island, Chernobyl, and Fukushima, the three big nuclear disasters that have happened in modern times. What has been the total human impact of those three disasters, 3 Mile Island, Chernobyl, and Fukushima?
Well, this is a very interesting issue of information in the public sphere being kind of misguided or misguiding, I would say. There's been polling when people are asked how many people, this question basically, how many people do you think died or got injured in 3 Mile Island or in Fukushima and Chernobyl, and next to 0% have what is the scientific consensus correct answer. Almost no one knows the answer to these questions, and that's part of what we're trying to address in the book. So 3 Mile Island, obviously, no one got harmed at all. Chernobyl, there is a statistical increase in cancer because there was a lot of radiation released. I think the consensus from the UN studies is potentially over time, if you use the most conservative model, maybe up to 4,000 people may lose their lives from that really severe accident. In Fukushima, there's one contested case where his death may have been contributed by him being near Fukushima.
There's also the irony that in the 1,000 square mile area around Chernobyl, nature has come bounding back because humans are not there. Tell us that.
Yeah, I mean, Chernobyl is a very interesting case in many aspects. Actually, the reactor next wall to the reactor that blew up, kept operating till the year 2000, which is it's absolutely bizarre when you hear it, but you can look it up. It shut down for a year, but basically was brought back online and kept producing power till the year 2000, which is insane. So the area is not maybe as apocalyptic as you might hear it is. And obviously when humans move away, nature can take over, which is kind of a nice twist.
Joshua, big concern with nuclear, of course, is about nuclear proliferation. You study international affairs. There's got a big concern about loose nukes, that material getting into the wrong hands.
Yeah, so backing up for a second on the safety issue, and then the proliferation is kind of a similar answer. Any fuel is going to have pluses and minuses, and nuclear power should be treated like others. There's costs and benefits, and you want to have a sensible attitude toward it. So to say like one accident happened, Chernobyl, and thousands of people died, you got to compare that with people that coal kills every year, people that, hydroelectric dams burst, methane gas blows up, natural gas, and so forth. So there's all pluses and minuses. And one of the minuses of nuclear power, although it's not well understood, is that the same material, the same physical process has a relationship to nuclear weapons and to nuclear power production. And that's a big reason people are afraid, especially those of us that grew up in the Cold War, because we hid our heads under the desks. We were terrified. We were traumatized by nuclear weapons, and rightly so. They're pretty terrifying. And then we kind of say anything nuclear, that's what it reminds us of. So a nuclear plant can't blow up like a nuclear weapon. That's an impossibility. And nuclear material from a civilian nuclear plant, in theory, could be accumulated and used to make a nuclear weapon with. But what we have is a system of international controls under the International Atomic Energy Agency, to which all but 4 countries in the world belong. And that system intrusively monitors all this material. They put cameras on the site, they put seals on the canisters, and sort of very carefully make sure that nothing is diverted out of civilian nuclear power programs. It's been entirely successful, and nobody's been able to make a bomb as a result of any failure in that system. Countries like Israel and North Korea that don't belong to that and have made bombs, they don't even have civilian nuclear power programs. And Pakistan and India also don't belong. They do make nuclear weapons and they have nuclear power, but they don't make the nuclear weapons from the nuclear power systems. It would be inefficient and uneconomical. They have their own, separate military reactors to produce plutonium for weapons, and then they've got reactors that are producing electric power. So we've managed to keep them separate. It's worked so far. If we have a big increase in nuclear power to address the climate crisis, we should ramp up those safety controls and do more and make sure that there's no failure. But so far, that system is working.
Sonia Agarwal, let's get you in on this. You did some early research on McKinsey cost curves and economics of various energy systems. How do you think nuclear fits in the market today in the mix?
Sure. So I guess I'll just start by saying it's absolutely right that we have to think about reliability and making sure that electricity is delivered affordably and reliably to everybody who needs to rely on it. And I would say that as we look at wind and solar, which are only available when the wind is blowing and the sun is shining, there's a huge number of technologies and new ways of operating the power system that can deliver that electricity just as reliably and as regularly as what are sort of traditionally base load dispatched power plants like nuclear or coal. We're seeing some numbers that I think are kind of nuts, honestly, not just for solar coming in or wind coming in, which are extremely low cost and have come down. Let's see, solar is 90% cheaper than it was 10 years ago. Wind is 70% cheaper. Batteries are 80% cheaper than they were. But that's kind of the key point to here, especially in this context of dispatchability and balancing the grid. Solar plus storage and wind plus storage in some of the most recent auctions are coming in at costs that are below the ongoing operating costs of existing coal plants. And that's just a crazy time if you think about it in a system that has traditionally moved very slowly. It's a pretty amazing moment. And we've seen the evidence of this. These are just the most recent auction results, but this has been kind of an inexorable decline over the last decade, and we're seeing more and more renewable energy capacity get built here in the United States as a result of that.